Hello and welcome back to this course on programming in Rust. So in this video, we're going to take a look at fearless concurrency. So we'll start running our code on more than one thread at once, doing several things at the same time. Now, in most languages, threads are where the scariest bugs hide, including data races, where two threads touch the same data at the same moment, and you're left with corrupted garbage results that are almost impossible to track down. But Rust's ownership system applies to threads just like it does everywhere else. So the compiler will actually catch those data races for you at compile time before your program has even run, which means that a whole class of the nastiest concurrency bugs in Rust won't even compile. So I've gone ahead and created a new project called Fearless Concurrency with cargo run. I'll just delete the hello world statement, and now let's take a look at how we can spawn and join threads. So let's write the following. So before we run this, let's take a look at what we're doing. So we kick off a new thread with thread : spawn, and then we hand it a closure, the chunk of code that we want the thread to run. Spawn will hand you back a handle, and you can think of that handle as a little receipt for the thread. Then you join on that handle, and that tells Rust to wait for the thread to finish before carrying on. So if I open up my terminal and run the project, we see the output worker 1, 2, 3, 4, and so on. So that join matters because without it, the main thread would actually race ahead, hit the end of main, and shut the whole program down before the worker even gets a chance to print. Calling join is essentially us planting a flag that says, wait right here until that thread has actually finished its work. And here's the important thing about threads. A thread can outlive the code that launched it. The function that spawned it might finish and clean up its variables while the thread is still running. So to stay safe, the thread has to own whatever data it uses, not just borrow it. For this, we can use the move keyword in front of the closure to hand ownership of the captured values back to the thread. So let's write the following. Okay, so let me open up a terminal, and we're going to just run this, and we should see our names printed out. So there we go. This is the ownership rules that we looked at earlier doing its job. Because the names have been moved into the thread, the code that started it can't touch names anymore. It's been handed over to the thread for good. And that's exactly how the compiler guarantees two threads can never both think that they own the same vector. Now let's talk about message passing with channels. So one of the safest ways for two threads to talk is through a channel. Picture a little pipe running between them. One thread drops values in at one end, and the other picks them up at the far end. And the good part about this is that ownership travels along with each value, so there's no shared memory sitting around for two threads to trip over. Let's write this and see how this works in action. Okay, let me open up terminal again, clear, and then cargo run, and we should get the message, hello. Fantastic. So I'll just get out of the terminal, and let's take a look at what's happening. So the TX is the transmitter, the sending end, and the RX is the receiver. You can see it there in the code. When the worker calls send, it gives up ownership of that string, and the main thread picks it up on the other side with receive. With that name, MPSC, it stands for multi-producer single consumer. So many senders can feed into one receiver, which is exactly what you want when a whole pile of workers need to report back to a single place. Now let's talk about shared state with Arc and Mutex. So sometimes threads do need to get at the very same piece of data. And for that, we're going to bring two types together. First, a mutex. That's short for mutual exclusion. And it's basically a lock where only one thread at a time can get its hands on what's inside, and everyone else has to wait their turn. Second is an arc, which is, we touched on this a little bit when we were talking about smart pointers, but essentially an arc is what lets several threads co-own that mutex to begin with. Let's write some code to see this all in action. Okay, let me open up a terminal, just clear this up, and we'll run it again. We should get a total of 15. So let's actually take a look at the code. So Arc is the thread-safe sibling from that RC that we discussed in smart pointers, and Mutex is the lock. 5 threads are each adding their own number, 1 through to 5. And because the lock forces their updates to take turns, the total lands on exactly 15 every single run with no race conditions. And here's the part that's really important. You can't even touch the number inside without calling lock first. That lock method is the only way in, and the compiler will hold the program to that. Without the lock, the code won't compile. So the safety here isn't a rule that you have to remember, it's actually built right into the types. So how does the compiler actually know what's safe to move or share between threads? It comes down to 2 little traits, send and sync. They're marker traits, which just means they're labels with no methods of their own, purely the compiler's way of tagging a type as thread safe. Send means a value is safe to move to another thread. Sync means a value is safe to share, by reference across several threads at once. Now, the best way to see what these do isn't just to kind of talk about it, it's to watch the compiler stop you. So remember the RC from the last episode? Let's try to move one into a thread and see what happens. Okay, let's try and run this. We're going to encounter a problem. You see, it doesn't even build at all. Because what the compiler has seen is that RC isn't send, and the thread spawn will only expect things that are. So it stopped us right here. There's no crash, no weird behavior, it's just a compiler error. So why is RC off limits? Because the way it tracks its own account isn't safe when 2 threads are changing it at once, which is the next race condition that we're trying to dodge. We already know the fix, it's Arc, which we talked about earlier. Arc does that same counting atomically, in a way that can't be interrupted halfway through, and that's what makes it safe to hand between threads. Now, you'll never mark anything send or sync yourself. The compiler will just work it out for every type automatically, and they're the rules underneath that can decide what can cross a thread boundary, and you'll run into them a little bit more when we talk about or go over our next project in the next video. So this is a good time to wrap up the video and really recap the main points of concurrency together. So when we create threads, we spawn a thread and join its handle. A spawn will start code running on another thread, and join will wait for it to finish before we carry on. We move data with the move keyword. So since a thread can outlive the code that started it, the move keyword hands ownership of what it captures into the thread. We pass messages through channels, so one thread will send a value down the pipe and another will pick them up, and ownership travels with each one, so there's no shared memory. Now to share state, we use Arc and Mutex. Arc lets threads co-own one value, and Mutex makes sure that only one touches it at a time. And then finally, we took a look at send and sync, and these are the gatekeepers. So they're marker traits that tell the compiler what's safe to move or share, which is how it blocks things like RC before your program ever runs. So in our next video, we're going to put all of this to work in our next project where we'll be building a fractal explorer. We'll build the whole thing, and then we'll make sure it uses every single core on your machine, with the compiler proving for us that there are no data races. It's going to be a really ambitious project. So if you like this video, give it a like. If you want to check out that video, make sure that you're subscribed, Any questions, put them in the comment section below, and as always, the code and other resources are in the video description. Thank you so much for joining, and I'll see you in the next one.